Hmm? All right, let's get started. Pleased to announce that we are going to have Reid Brosko and Evilgrade discuss something that was old and new again.
Yep, she didn't hear it, so we'll just go on. All right, so I'm going to go over a little talk we put together. I like to do technical talks, especially at the end of the day. Everyone's had their ear talked off. Death by PowerPoint. This is a little bit more fun. You get see a little bit more granularity into some of the things that are out there, that are new, that are making resurgence. Today I'm going to be talking on an older tool called Evilgrade. Evilgrade has been around for a long time. And yes, this deck is fueled by Red Bull and bourbon, so you will have some interesting slides, and I don't remember creating all of it. All right, we'll go over introduction of myself, kind of what is Evilgrade, kind of go over some of the attack methodologies, the structures, the attack vectors, and how it can be used within the environment, and why it's now making a resurgence, and why you're seeing it being used again. And then we'll go over at the end some of the preventative measures you can do to help prevent this kind of thing to being used against you. Oh, that's a little lower, but okay. All right, so start out. My name's Reid Brosko. I work for CBI, Creative Breakthroughs Incorporated. Check out the booth at the front for the CTF. There's some great prizes. And then check out the recruiting booth at the end for some additional stuff about CBI. I come from a DoD background. I come from the Marine Corps, worked with the MARSOC and a Yankee White establishment. I hold a top secret Cat 2 clearance that I've used within some of the jobs that I've done. Just recently, last year, got my CISSP. Been involved in the IT field for about 7 plus years. Been an active red team pen tester for about 5 years. And I've got to play in a lot of different environments. Everything from food processing and manufacturing, ICS SCADA environments, to gaming as far as casinos, working on the casino floors, working on the casino securities, working on the entire establishment. The banking I've been playing in from everything from mobile banking to the actual banking infrastructure and the web application pen testing and their actual applications running there on your phones. And then DoD and military. I've gotten to play around in some DoD infrastructure, stateside as well as international. Played Tiger Team, played Red Team, played Blue Team, played everything like that. So I've got a nice little smattering of, splattering, whatever you want to call it, of different areas I've got to play in. Currently working with CBI, I'm a lot more the corporate guy. I'm the red team that are stepping into these corporate environments around here that are saying, hey, we don't want to be the next front page. Here's our network, or go at our network. Tell us where we can fix it. So that's what I've been doing for the past year or so. What is Evilgrade? Like I said before, Evilgrade is a framework, a module framework that utilizes weaknesses within update functionality as well as update callouts to help compromise hosts. This originally showed up by a company called InfoBytes around 2008. So it's been around for a long time, and it's just now making a resurgence with the addition of plugins with Veil, MSF Venom, and Shelter. If some of you saw Sean's talk earlier of that escalated quickly, this would be categorized more of a Hail Mary in the environment. This is all else fails. This is let's throw everything, the kitchen sink and the keyboard at the environment to try to gain that access or that additional foothold into it. One big thing that made Evilgrade so big when it first came out was that it's all pre-made agents. You're not having to go in and configure anything within the device. These are coming canned straight from InfoBytes with updates for when it first came out was WinSCP, FileZilla, Windows updates. So these are all things that you can use to try to man in the middle of the update process. It was very easy to set up. It came with its own web server as well as DNS server, because you do have to do, I'll go over a little bit later of the methodology of it, but you are doing DNS or DNS spoofing and DNS man in the middle. So it came with all those. You don't have to stand up anything additional for it. It's all pre-canned. It's an open source project. It's been continuously updated. Even as far, last time I checked, it was, I think the last update of a module was added about a week and a half ago. So it is continuously being updated. People are out there adding to it. And it's multi-platform. This isn't saying, all right, I can only go after Windows 32. I can only go after Macintosh. You can go after phones. You can go after Macs. You can go after Windows 32, 64. But the only limitation is the payload. With that payload being delivered, however you package it and deliver it, that is the only limitation. So, yeah, I'm flying through this. This won't go full. Going through the attack structure as far as the methodology will be used, kind of where you can use it, where what it can do, and other things. Big thing with Evilgrade is that it can be used externally as well as internally. Externally, you're looking at things. If you gain access to their DNS, I mean, they've got bigger problems than Evilgrade, but if you can externally gain access to internal DNS, that's the easiest way right off the bat to be able to man in the middle anything. But DNS cache spoofing, there's countless tools out there. EtherCap, Metasploit's got a module of the Bailey Wiki host. DNS Chef, my favorite, the Paranoid Penguin, are all just open source tools that are great for a DNS cache poisoning or spoofing attack that can get you into access to the DNS to add a record in there from external. Fake access points is another thing that this has been used with a lot of pairing. Things like DNS mask, airbase, fake IP, evil twin, standing up an access point and then basically just implementing a whole list of the plugins and basically spray and pray, hoping that something on their computer, the QuickTime, the Apple, or the iTunes, the WinSCP, something like that calls out for the update when they're accessed your fake access point, and you've got them that way. Internal is a little bit easier. You've got access to the internal network. Now, once again, brute forcing to gain access to DNS server, ARP poisoning spoofing, tools like Subterfuge, ARP spoof, Kane enable, EtherCap are all things that can be used and have been used to get that foothold for the man in the middle attack of Evilgrade. DNS caching and poisoning, same thing as the external, and then the DHCP spoofing. So go over kind of the basic normal update process. The app, whatever calls out and says, hey, I need an update, and reaches out to their update server, app, update.app, whatever. That DNS server points it to the IP. That app goes, okay, this is the latest update, grabs that update and executes it on the box. Very basic. Now the malicious aspect, you're stepping into that second piece. Right when that DNS server cache, or when that application pulls down and says, okay, what's this web directory or website pointing at, that's where the man in the middle attack with that DNS spoofing, DNS middlemaning is going to take that DNS, that IP address, and point it directly where you want it to rather than where it was going. With that control, now you can say, all right, yeah, I'm on the update server. Here's the update you want with my code now in it. And it says, okay, yeah, that's fine. Here, take that update, downloads it, executes it, because a lot of the times, older versions of these applications, we're not looking for certificates. We're not looking for digital signatures or anything like that. It's reaching out and saying, give me that update. All right, you've got the update. Give it to me. I'll execute it. All right, we're up and running. Attack vectors. This is kind of where we can get into some of the fun stuff. This is the scary part. These are all of the pre-canned modules that come with Evilgrade. These have been added over the years, and a lot of them, a lot of the bigger ones, the newer ones, the Lenovo, the VMware, the Samsung, are the reason why this is making a comeback. Dell just had a recent one where they had an update process on one of their applications that was not calling for digital signatures, that ended up in a vulnerability referred to as eDel root that was utilized by Evilgrade to push updates, malicious updates to corporations or companies that had been compromised and had a CNC server on it. The ASUS the same way. ASUS had a pre-canned ASUS updater on laptops. If those laptops were connected to a malicious environment, they had they did not call for a digital certificate and were allowed to be compromised. Samsung, same way. The Samsung was more on the TV side, or you've seen some of the TV exploits of being able to pull up the webcam on a TV. Evilgrade had a module that when that TV called out over Wi-Fi or LAN looking for updates for the firmware, it was not being digitally signed, it was not being checked, and you could man in the middle of that very easily. The Intel one was the most recent one. This was dealing with Intel driver update, a little Intel module on devices that said, hey, we're looking for the latest updates. That is the latest module that has been added and changed, and that was a recent use of, we have seen, of Evilgrade. Oh, there's a fun one. I knew they were in here somewhere. So, as we all know, live demos don't work very well, so I decided to do screen captures at the last minute. You'll see some of them that are blocked out because I was doing it. My boss is here, but my boss isn't here. Doing some of it at work and some of it at home. So, so we can start out. The biggest thing, right off the bat, it's not the traditional aspects aren't going to work. You need to pair it with, and that's why it's making the comeback now, pair it with a Venom, with a Veil, with a Shelter to obfuscate that payload code in the back end, because antiviruses within PCs or anything like that will still catch it. So that's what the first thing is. You're seeing me create the actual payload in the listener with MSS Venom, just using a traditional interpreter session. This is Evilgrade. Evilgrade, open source, pulled down from GitHub. That's what it looked like when it loads up. Don't worry about that. They're just loading the modules. This is a list of all the modules. What I put up there on the screen, you probably can't even read it, but what I put up on the screen a second ago is not a complete list. Those are just some of the bigger ones that you may know within the environment. This is the complete list, all of them for you, as well as a additional document, because it continues to go on lower down on the page that I couldn't even capture. But once you basically choose one of the modules to use, like I use this one, easy one, Notepad++. So many developers, coders use Notepad++. It's been updated, so I use that one. You simply tell it, I want to configure Notepad++. Show options, very similar to Metasploit of just show options. It'll give you what you have options to do. Within the options, it says the agent. The agent is actually what you want it to do, what you want it to execute. I simply told it that, as we said, within the root directory was the payload that I used, the notepad shell.exe. Out, bracket. Basically, when it runs, I want you to run this packet, this payload that I've got stored right here. Next thing you need, fun part now, is the DNS spoofing. So using EtherCap, basically, the next one, this is better. So you can see within the module, within the show options, it'll tell you what the call out of the application is, what you need to spoof the DNS to. So I simply say, put in my EtherCap DNS man in the middle, anything reaching out to that, point it back at myself, point it back at my machine hosting up my my malicious payload. With that running, now we go into the EtherCap and basically start the DNS spoofing aspect of EtherCap to say, all right, any traffic traversing this network, grab the ARP and, oh geez, I hate this little clicker. Okay, that was a fun one. We're starting it up and telling it anything traversing that network, grab it and point it back to me when it hits that directory, and we can see it seeing different hosts within the environment. There was a few things pre-canned within EtherCap. You saw it trying to man in the middle Windows update, which was kind of funny. Now I just next thing is just starting my interpreter listener on my box. Sending out the payloads. I've got the listener started. I've got the DNS man in the middle started. Once that machine opens up, my victim machine opens up the actual notepad device, you can see it call out and spoof happen here. You can see me start the web server grabbing connections here. And you can see on my interpreter, my Metasploit, you can see the session being generated. Oh, there's another fun one. I think that's it. But so some of the additional options, like I told you about, this being paired with the MSF Venom, with the shelter, any obfuscation tools out there within the environment to hide that payload within is key. Everything's out there right now knows interpreter sessions, knows other Metasploit modules and stuff like that. So another great way is, instead of using a module, use something like a netcat. Have that push out and execute netcat on the device. Or have it push out if you don't know if it's running PowerShell. Have it push out and all of a sudden open PowerShell and call home over PowerShell. PowerShell's trusted. You see that with Empire and things like that. So Empire is a great new tool because everything's running PowerShell. Have this, if you can't get into it and not know if it's running PowerShell, have this push PowerShell to it. Updates, as I said before, the GitHub updates over Evilgrade are continuously being updated, so it's always a great thing to check. Prevention. Wow, I went through this way too fast. Biggest thing from this is ensuring your update servers are running over HTTPS. A lot of these, put this down. A lot of these older applications, Notepad++, some of the open windows and stuff like that are notorious for running over HTTP, and that's where the execution, that's where some of this man in the middle becomes a lot more easily done. Running the updates over HTTPS using certificates for controls helps prevent a lot of these the man in the middles from taking place, and ensures that update cannot be pushed. The DNS you cannot man in the middle it or anything like that. Digital signatures and use of public keys. So the checksums, digital signatures to ensure that packet is where it, or that update or that package or anything is where it's coming from is paramount. If you don't know where that's coming from and you can't say that absolutely was not interrupted or that was not manipulated from the origination host, you don't know what's in it. And then the last one, as always, end user education, continuous security awareness is key. You can throw every piece of equipment at the environment, and if users continue to click on things, update things, and not do what's best practice, it's not going to make a difference. Okay, that's... Any questions? Yes?
So these packages, maybe set along with the math bulk update package, so like when we're like, oh, we've got all these updates, does it get thrown in there, or is it always separate?
It's always separate.
Okay.
Yep, it's basically just, because you're not pulling anything from the actual legitimate update source. You're basically just saying, it's reaching out to here. I'm not going to let it reach out here. Once it reaches out to that point, I'm saying, no, it's over here. And it's just giving you my malicious traffic. Any other questions? Yeah.
This is taking advantage of older applications.
That is, yes, but we are seeing like that Intel update was a newer version that was running just continuously. They weren't following best practice of ensuring over HTTPS or digital signatures on those updates. So you saw updates from there. I believe the last time we saw it live for a iTunes or Mac was early 2016. They've moved to all secure updates, but it has worked with that. The original thing that this was meant for and created for was to man in the middle of Windows updates, and it was damn good at that. But I have not seen that go live within Windows updates or been used in the wild in Windows updates in a while. Any other questions? Mm-hmm.
So your ARP spoofing is for the man in the middle?
Yes.
Okay, so I'm wondering, have you ever, because I actually did some tests before where I was spoofing the gateway on a network.
Mm-hmm.
And I found that people in the office actually were using some programs that actually notified them, hey, there's something weird going on the network.
Yeah. A lot of times within networks, things like XARP and NoARP and other things like that will prevent or that will notify and prevent ARP spoofing or anything like that within the environment is a huge prevention.
Have you seen like user applications for that? Because I think Skype possibly actually, because I was using Skype at the time. When Skype released, it actually said, hey, we see some weird ARP stuff going on.
No, I haven't.
Skype, and there was some other application I was using that I found that kind of interesting.
Like semantic endpoint protection is capable of detecting ARP poisoning and SMB relay attacks to responders. So I found that interesting when they started to pick up on that. But yeah, the security on the application side is interesting. Maybe it seems like certificate mismatch or something, because Skype, I would assume, would be one that reaches over the secure digital channel. Right.
Mm-hmm.
Yeah, semantic was the other one too.
Yeah, the new Symantec products, except 14s, are making my life a living hell. Anything else? All right, I'll give you some time back in your life.